No questions? Okay. So I just want to ask a couple of questions. Um, do we understand what an acid and what a base is?
Yes.
Sean, can you give me a very basic interpretation of an acid and a base?
Acid is anything that has a pKk below 7. A base is above 7. 7 is neutral.
Okay. Yeah, so if something has, I don't think I think you said pKa, right?
Yes.
Yeah, okay. I don't think they talk about pKa's in here. But basically what he's talking about is depending on the molecule's pKa, if it falls below or above that, that is when that thing will become deprotonated. So, but we're not going to talk about pKs because that's too much. All we're going to be doing today is we're going to be looking at a set of different solutions, and we're going to be determining whether they're acidic or basic. So to kind of simplify what he said, an acid is anything that increases the level of free hydronium ions, so positively charged ions, and a base is anything with free hydroxide ions. So anyway, so yeah, it talks about that in here. I'm assuming you guys have all already read the pre-lab. So if we could just look here really quick, and this table 1 and the relationship between the hydronium ion and pH. And normally I don't see this annotated this way, this H30 plus. I normally just see it as a plus H, but this is also annotated this way as well. And all this is saying is that this H2O has an extra hydrogen, so it's positively charged. And as we go, so if you see here at the 1 molar concentration, its pH is 0. And as we move down in concentration, so as the concentration gets less and less, we move further and further away from 0. And so by the time we get to this 1 to the 10th to the negative 14th molar, we're at 14. And so the higher the pH, so whenever someone says the higher the pH, they really mean the lower numerically. So when they say a high pH, they mean something between like 0 and 4. If they say low pH, they mean something between 8 and 14. So I know it's kind of weird because you think low like a smaller number, but when it's lower, it's actually a bigger number. And when it's higher, it's a smaller number. And again, you guys have already read about the litmus indicators. There are specific ones for bases and acids. And here are a list of different indicators. If you guys have already read the procedures, we're using thymol blue, methyl orange, and phenolphthalein. And if you guys see for the thymol blue, it actually has 2 different sets of what's called ranges. 1.2 to 2.8, where it turns from red to yellow. So as it goes from high to low, it turns from red to yellow. And 8.2 to 9.1, it turns yellow to blue. So methyl orange and phenolphthalein only have one range. And we're going to need to know these for our indicator tests. So let's go ahead and get started on the video. I'm gonna okay, it's already at that speed. So those are your materials you'll need. But you don't have to write that down. And so you're going to have 3 test tubes, and they're each going to have different solutions in them. And you're going to use those 3 tubes to test whether the current a solution is basic or acidic. So, and just like it says here, just record all the colors that the litmus strips change to.
Where do we write that down? Because I don't see anything for the.
Right. Oh. Yeah. So our first solution is going to be the HNO3, and it is way down here. So for the pH of aqueous nitric acid, has the blue litmus, red litmus, thymol blue, methyl orange, phenolphthalein. And so this is where you actually write that here. You can write it there, and yeah, just there. And or here too. You can also add it to this table, but they give you a whole separate one just for nitric acid. So what does that look like to you guys? Is it changing red on the blue litmus paper?
Yeah.
Yep. And then on the red litmus paper, is that changing colors at all? No. So just based on this, what would you guys assume? Is it more of an acid or a base? I mean, and it's also in its name, so that kind of gives it away. All right, it's probably more of an acid, right? It's called nitric acid, so. So now we're going to do 3 drops of thymol blue. Keep in mind, thymol blue has those 2 different ranges, methyl orange and the phenolphthalein. Okay, so we have those three. So for the thymol blue, what color did it change to?
It's red, right?
No, it's more of a pinkish. The one on the far left, it's more of a pinkish color. And the one on the in the center,
That's straight up red, yeah.
that's straight up red, right? And then the one on the right for the phenolphthalein
So that's colorless.
is colorless.
Well,
Okay.
we already know from the thymol blue it's in that range of 1.2 to 2.8, and the red in the middle just confirms that further, and of course the colorless does too. But
Right. Exactly.
I'm just not used to I don't know what the color scale is because I haven't used this for a bunch of, you know what I mean?
Right. Sure. Sure. Yeah.
I don't know how red that can be.
Mhm. So yeah. So let's go back up here just real fast to the chart. Okay. So yeah. So for thymol blue, right? So it goes from red to yellow, so from 1.2 to 2.8. So it's not quite red and it's not yellow. So what would you think its pH is? Like if you just had to take a guess.
Like in the middle of that range, like 2.
Yeah, like 2. Yeah, I would say probably 2. Something in between there. So I don't know if red and yellow make pink, but yeah, that would be a fair answer. So let's go back down. Oops. Okay, so is this an aqueous? Is an aqueous solution of nitric acid acidic or basic? We just talked about this.
Acidic.
Acidic. Okay, and what evidence do we have to support that?
The litmus paper turned red.
Okay. The what litmus paper? Which one? Because the blue litmus paper corresponds to
The blue one.
yeah, the blue one. And what else could you say? Like what else do you have here that would support that?
Methyl orange turned red.
Methyl orange turned red. Okay. Yeah, and you could also say the thymol blue turned pink. So if it would have turned yellow, you know, for depending on like what the color methyl orange turns to and phenolphthalein changes to, you can almost definitely say it's not acidic, but you can't say whether it's basic or not. But you know, here in this case, it didn't turn yellow, so it is acidic. So here it says, using the table 2 and the color indicators, estimate the pH of, okay, and that's what we just did. And we said around 2, right? Okay, so moving forward. So here we see for H2SO4, we see that the litmus paper turned red, the blue one did. And the litmus paper just stayed red. Um, yeah. I'm sorry. Did it say unknown? Is that what he wrote on there? Let me go
You know,
back
it was
here.
sulfuric acid, wasn't it? Or
Yeah, it's supposed to be sulfuric acid.
it does say unknown on there.
Yeah. But
Well, it was pretty acidic, whatever it was.
yeah, I don't think it's supposed to be that though. I don't think it's supposed to be an unknown because you don't have any, because the point of this lab isn't to determine an unknown. Yeah. Okay. Anyway, that's weird. I didn't even catch that on the first time that we watched it.
Yeah, it's like at least like slightly more acidic than the last one. It's closer to the red, I think, on the thymol blue.
Yeah.
So it's like whatever, I don't know, 1.6, 1.8 or something, maybe closer. I don't know.
Yeah. Did you guys all catch that though? The colors of this unknown, which I think is sulfuric acid, but yeah, so it's pink or like a deep pink for the thymol blue, magenta, whatever you want to call it, red, and then colorless. All right. So now we're doing acetic acid. I'm sorry about that. And so the acetic acid, the litmus paper, the blue one turned red and the red one stayed red. And so we see here for the thymol blue, it turned yellow. The methyl orange stayed red, and for the phenolphthalein, stayed colorless. And so, and also, guys, it should be going in order here. So A, B, C. So next we have, and that's why I was confused about the unknown. I think that's just supposed to be sulfuric acid. So sodium hydroxide. So he adds that to the blue litmus paper, stays blue. And here, let's see. And the red litmus paper changes to blue. Okay. So yeah, go back one more. So yeah, so for the thymol blue, looks like it changed to blue. And for the methyl orange, changed to orange. And for the phenolphthalein, changed to pink. And based on those values that we saw earlier, what do we think? Is this a basic or an acidic solution?
Basic.
Basic, okay. And also by the litmus test as well, right? And now we're doing this, NH3 and H2O. Or ammonia water. Here we see that the litmus blue paper stays blue and the red paper turns blue. Okay. Then the thymol blue. And thymol blue turns blue, methyl orange turns orange. And the phenolphthalein, like a slight pinkish color, very slight, very, very slight. 4D. So moving forward, I'm doing sodium bicarbonate. The blue litmus paper stays blue. And well, I think he's gonna add a little more. And the red litmus paper turns blue. Or on E. So thymol blue, blue, methyl orange, orange, and the phenolphthalein turns pink. So make sure we get that down. And then it looks like we're skipping F, going to G. And let's see if we, nope. So it looks like the blue paper stayed blue and the red paper stayed red, no? Does it look like those changed very much? No, I don't think so. So the thymol blue, for G, it turned yellow. And for methyl orange, turned orange. And phenolphthalein stay colorless. And so now we have to answer questions 14 through 21 and do your post lab and upload that to Canvas. So does anyone have any questions about the video? Need to like see something again on the video? No?
Do we just need to state that we didn't do F? Just like put a line there, not applicable.
Yeah, because yeah, he didn't have it listed. So, so yeah, just I don't think you have to write it down. Just if it asks about it, then just put NA or something. Because I mean, I'll be the one grading it, so I'll know. So list each of the solutions tested that is acidic. So which ones were the acidic ones? Do we remember?
The sulfuric acid, acetic acid. Did we do nitric acid would be acidic?
Yeah, nitric acid would be acidic.
I mean, sodium hydroxide was basic. That's all. I don't know. I don't remember the rest.
Sodium bicarbonate was basic. The last one was ammonia chloride. But
I think the ammonia chloride was more neutral than
yeah. This is what it seemed like, right? And so yeah, so based on these observations, just write those down in your data sheet. And this isn't be a stupid a question, but do you guys have to turn in these data sheets? I don't think you do. Do you? You just turn in your post lab, right?
I've been putting it in as part of the post lab.
Okay, yeah, then just keep doing that. If you haven't done it, it's okay, but if you have been, just keep doing that. So then we have, other questions that say ones that are more basic and ones that are slightly basic. So you're gonna have to kind of go back and see, okay, like which ones turned more blue, which of them the phenolphthalein, did it turn more pink or less pink? So and that's the reason why we're using 3 different indicators, is to try to like refine how basic or how acidic something is. This is a pre-lab assignment that you should have already done. And your post-lab questions are just conceptual questions for the most part. Just try to think about, I know a lot of these for the questions are things that we saw during the video, so I feel like I should be able to answer those questions. Does anyone have any questions about the post-lab questions? Do you guys feel pretty confident that you guys can answer these? Okay, yeah, and this will be posted to YouTube, so go back and watch it and answer those questions. So if that's it, and if no one has any other questions, I'm gonna go ahead and end lab now. And you guys all have a great weekend, all right?
You too.
Thank you. You too.
Bye.